In this recording, we're going to learn how to use some of those trig identities you just learned about to simplify trig expressions. We're going to take complicated expressions, make them a lot simpler. Basically turn them into a number, like a 1 or a 0, or possibly another trig expression like a cosine or a cosecant squared theta. Let's take some notes. I'm going to give you some tools that will help you when you're simplifying trig expressions. So first off, you got to know your trig identities, and so far we know 7 of them. Okay, you just learned that in the last video. We got 2 quotient ones, you got 2 reciprocals, and you have 3 Pythagorean identities plus 2 alternate forms. Okay, those tools are at your disposal. You should have those out while you're working on these so you know what to look for. Secondly, we should know what to do to add fractions. We need to get a common denominator to add fractions. For example, if I'm trying to put together 1 over cosine plus sine theta over 1, I need a common denominator. I need both denominators to be cosine theta, so I'm going to multiply the numerator and denominator of the right fraction by cosine theta. That allows the denominator of the overall fraction to be cosine theta, and then I can just add the numerators. 1 plus this expression sine theta cosine theta. That's what's in green. Finally, if you want to simplify a complex fraction, you would know that we multiply by the LCD of all those little denominators. And we've done that often in this year, but it's going to come up, be really critical in these trig expression simplifications. Next, I'd like to give you some tips based on my experience doing this. I think this will help you. I got 2 tips for you. First one, if you have a squared term, like say cotangent squared theta, you should think about using a Pythagorean identity. I'll give you some examples of this, but just to write this in your notes. Okay? In other words, if you see a square, look to your Pythagorean identities. Make that your first inclination. It also sometimes helps to use an alternate version of an identity. For example, that main Pythagorean identity, sine squared theta plus cosine squared theta equals 1, we can rewrite that, as we pointed out in the last video, by subtracting cosine squared theta from both sides. So you have something that's just sine squared theta all by itself. The second tip is equally as important. If you don't have a squared term, try to rewrite all the expressions in terms of sine and cosine. You might have noticed that all the quotient and Pythagorean identities could be written with sine and or cosine. Finally, a common error to avoid. S goes with C and C goes with S. Do not say that secant theta is the reciprocal of sine. Secant theta is the reciprocal of cosine. Okay, and cosecant theta is the reciprocal of sine. So make sure you get those right. S goes with C, C goes with S. We're going to look at 5 together here in this video, 5 simplifications. We'll start with some easy ones, work a little bit harder, and then I'll give you 4 to practice. Okay, you'll bring those to class. Okay, first one, simplify the trig expression. Okay, let's think about those tips we just looked at, we just wrote down. It said if you have a squared expression, you should use a Pythagorean identity potentially. We do not. So our second tip was, well, if there's no squared expression, try to use a substitution in terms of sine and cosine. So let's do exactly that. We know that cosecant theta is 1 over sine, and tangent theta is sine theta over cosine theta. You might notice that sometimes when I'm speaking this stuff, I don't say the theta. That's okay, but you have to write the theta, because the function by itself doesn't make any sense without the angle. It's like a square root with nothing underneath. A function needs an argument. Next, let's try to simplify this. Well, of course those signs divide out, right? It's just a variable on top, variable on bottom, so that leaves us with 1 over cosine. Look up in your identities and find a different way to write that with no fraction. And hopefully you realized it was secant theta. You just did it. You just simplified a trig expression. Great. Let's try another one. Okay, try to do this one on your own and play the recording when you've got it. Okay, so hopefully you worked this one on your own. You wrote sine theta just as it is. It's all set. Doesn't need any substitution. There's no squares here, so we're not going to look at any Pythagorean identities. But cotangent theta can be made into sines and cosines. So look up on your list. It should be made into cosine theta over sine theta. Well, great. Well, here we just divide out our sine thetas, and then we're left with a cosine theta. Simple as that. Our next example, well, we've got a cosine theta, which I'm going to leave alone. I don't see any squares here, so I'm not going to invoke any Pythagorean identities yet. I'm going to leave sine theta alone, and I'm going to change tangent theta into sine theta over cosine theta. Use an identity there. Okay? Great. Next thing is, I'm going to put these together into a single trig function. Now when I multiply those, I'm going to get a sine squared theta, right? Secondly, I'm going to need to add two fractions. So I have to think about what denominator I'm going to want on the left side to match up with the denominator on the right side. Okay? So hopefully you realized we're going to have to multiply by the LCD. We're going to have to multiply the top and bottom on the left by cosine theta. Cool. So on the right side, when you multiply sine theta by itself, you get sine squared theta. And the same thing on the left side, you get cosine squared theta. Now we're in a position to add these two fractions. They have the same denominator, so we add their numerators. And it looks like this. Now you might say, well, that looks so complicated. That did not get any simpler. And you're right. So let's make it simpler. This numerator can be written by a single line. It looks so complicated, but look back in your identities. We said if there's any square in it, you want to look at a Pythagorean identity. And isn't that the first Pythagorean identity? It's just reversed. So that can be written just as a 1. And then 1 over cosine is just secant. That's about as tough as they get. Number 4. This one has a fraction already, so we know we're probably going to be getting a complex fraction. So why don't you substitute what you know for each one of those 3 trig expressions and then play the recording. Hopefully you made substitutions. You put a cosine over sine for cotangent, you put 1 over cosine for secant, and then 1 over sine for... Now, we clearly have a complex fraction here, and we might be tempted to go in and multiply everything by the LCD, but let's look carefully before we do. Can you simplify this numerator? Well, sure. We can divide out those cosines. So let's just divide the cosines, and on the top you have 1 over sine theta, at the bottom you have the same exact thing. Well, that's just a 1, right? You can leave this intermediate step if you like, make them both into cosecants or not. Either way you got a 1. Alright, our last example does have a squared term, so you should look over your list of Pythagorean identities, and you should try to find one that has a squared term in it and cosecant. Hopefully we found the one that says cosecant squared theta is equal to 1 plus cotangent squared theta. So what I've got underlined here in red, you can replace what's in red. We're going to distribute the negative sign, the negative 1, to both terms in parentheses. And I've just got 1 minus 1, you guys all know what that is, minus cotangent squared theta. So the 1 minus 1 just is 0, and our final simplified form is 1 minus cotangent squared theta. You've had a little bit of exposure to this. Here's your opportunity to practice. So I'd like you to write down these 4 examples, try to figure them out, simplify them, bring your answers to class. Thanks for watching.